चलो एक मौका मिला था वो भी हम. Good evening students. So welcome our class. So today we are going to cover the second part of code of Pythagoras theorem. The code of Pythagoras theorem. The first part is already covered, already discussed with you in our channel. It is uploaded. Please check out it. The main concepts all are covered there. So some other parts are left out. We are going to cover here. Okay. So let's get into it. As these are the contents, let us revise on. We have multiplication and of standard Pythagoras triplet. We have code of Pythagorean triplet. We also have table of Pythagoras codes. Also we have seen some observations of code table. Up to this three part we have covered. Today we are going to cover this observation, some problems, and we will discuss some advantages and disadvantages of code table. So the three parts are already covered with you. So please check out on our channel. The link of the video is also will provided you in the description below. Okay, and also you check out this I button. It is also showing over here. Okay, so let's go into it. So I want to revise once again the table of Pythagoras codes. So as I already told you that our procedure is that here we all writing base, here we considering perpendicular, and the resultant of these two is coming what, hypotenuse. And I also shared with you one example, which is this one. Suppose this is 3, this is 4, you will get 5, or I can reverse also it. You can write here 3, here 4 also. Okay, I have told you this one because let us, by revising this table only, we can see the observations. So I have considered base 0 and all this entire row as a perpendicular, and basing on that, this is the value you have to got. This is the value you have to got. Okay. Similarly, if you consider, let me erase. If you consider base, typing problems actually occurring. If you consider 1 as your base, and from 0 to 10 this row you consider as perpendicular, then you will get, this is the resultant. If you see 1, if you see 1 and 0, you will get 1, because 1 square plus 0 square is what, you will get 1, and also 1 square plus 1 square, you will get 1.41. But decimal is not important, but we have to see that decimal is coming after how many digits of number, and what is the number is there before decimal, that you have to consider. So before this decimal point 1 is there, so we have write down here 1 and 1, we have write down this 1. Okay, so likewise 1 and 3 you will get 3, 1 and 4 you will get 4, 1 and 6 you will get 6. Not only this one, but also if you consider like this, 1 as your perpendicular and this entire column from 0 to 10 you consider base. Also you can see the resultant, this will be the resultant has to come. Okay, uh, yeah. Okay, once again one error is there, we are correcting it. Just a minute. 4 and 4, right? In last class I have shown you this one will be 5. Okay, so please correct it down. This one should be 5. Okay, so now you see this table. Hope you have corrected it. So you see about the diagonal. Oh, sorry, I have sorry students, I have erased wrong one. Okay, if you see about this diagonal, so yeah, I have already told you that this is the part of class 11th and 12th. They have studied this matrix. This is called as matrix. If you see this diagonal here, this will called as upper triangular matrix and this is called as lower triangular matrix. Just so one. Okay, sorry. See. So suppose this is the matrix. Let me draw it bigger. Consider this as the matrix. This is called as matrix and it is denoted with a capital letter A. Okay. So if you consider 3 by 3 matrix, it means it is 3 rows like A, B, C, A, B, C, D, E, E, means 3 rows and 3 columns. Okay, don't worry about it, class 8, 9, 10 student. You just listen what I am saying. So if you consider in matrix, we always consider this one as the diagonal. Each element is written as like this: A I cross J, where I and J will denote the positions starting from 1, 2, 3, 4. If you consider this one, it is the first row, starting from first row and from first column. So it is the position is A11. If If you consider this one, it is in second row and second column, so we consider A22. Similarly, this one is A33. So if you consider about this diagonal, you can see that this triangle and this triangle. Okay, this is lower triangular matrix and this is upper triangular matrix. And it is the smallest matrix in which the triangular matrix can occur. We also have 2 by 2 matrix 1, 2, 3, 4. You consider this is diagonal, these are just elements, these are not triangular matrix. Okay, so you see the triangular matrix have having symmetry about the positions. It is called as A2 by 1, it is A1 by 2. Just changing the positions, your element is same. Your element is same, and here also it is same. C and C. The elements are also same here. Okay. So likewise, this is an 11 by 11 matrix. It is a 11 by 11 matrix because starting from 0 to 10 it has 11 element. From this 0 to 10 it is 11 element. So this is the matrix. Yeah, from this is the matrix. Almost of course it is not observing like a square, but the number of elements are 11 and 11, so it is an 11 by 11 matrix. So this lower triangular matrix and upper triangular matrix are symmetrical. Okay, and because of symmetrical, you will find one interesting thing, that the determinant starting from 3 by 3 matrix is always coming to be 1. We will show you. Okay, so let us go here. So I have discussed first observation. That is one of the observation. Here it is another observation. So it is the same table as we have shown before. So in this table, you see we have drawn one line. Wait, we have drawn one line like this, and you see about this line, it all coming to be symmetrical. Up to last, you see it is all coming symmetrical. Starting also 10, here also 10, third point is also 10, here also 10. Suppose the sixth position is 11, here sixth position 11, so 10th position 13, 13 it is 14. If you likewise see here, it is also coming the same. Here 9, here 9, here third position 9, here also 9, sixth position 10, here also 10. Suppose 8th position 11, here also 11. So you can observe that it is coming about this line symmetrical, and we have drawn the two lines for same base and perpendicular. You see, this is 4 and this is 4, so the line drawn is about 4, and up to here I am not going that side, I am not going this side, because uh, you can go like this also. Let me clean it, just showing one more interesting thing. You can go like this. Just a minute, students. I'm showing you. If you're going from this, starting from here and going in this direction, also you can see it is symmetrical. Starting from this direction, it is also symmetrical. Likewise, it has to become. Okay, fine. So this is very small thing, but the main thing I have shown you the symmetrical. Okay, next observation. So it is also saying the Pythagoras chord table is symmetric above the diagonal. So you see this is the diagonal and this is the lower triangular matrix and this is upper triangular matrix. This is the upper triangular matrix. Both are symmetrical. It is upper triangular matrix. This is lower triangular matrix. The triangular matrix which is below the diagonal, it is lower triangular matrix. The triangular matrix which is above the diagonal, it is upper triangular matrix. In short, I have written. Uh, okay, 11 students. So the next point is the determinant of any n by n matrix. It is written wrong. This has to be n is greater than 2 because at 2 by 2 matrix it is not always 1. Okay, so take one example. Uh, Let me go back. We will consider first this one 3 by 3 matrix. 0 1 1 1 1. Wait. Think 1 also will come. Sorry, 0 1 2 1 2. 0 1 2 1 2 and 1 2 1 2 1 2 1 2. It is 3. Okay, this way it is given. Okay, so please observe it very carefully, class 8 to 10 students, how to calculate the determinant. So consider this is A and its order is 3 by 3 matrix. So I am going to find the determinant of A. That is determinant of 0 1 2 1 2 1 2 2 3. So first of all, taking this element and we will take this matrix. So you see it is coming 1 into 3 minus 2 into 2 and then the symbol will change minus 1. Now you consider this and this. Okay, so 1 into 3 minus 2 into 2, it is 2. Okay, now consider this with again changing sign plus 2 into, you will get this 1 into 2 minus 1 into 2. So if you see this is multiplied with 0, so it will be coming 0 and this is also 2 minus 0, so left with this one minus 1 into 3 minus uh, 3 minus 4, it will give you 1. So the first one is done for you. Now second one, let us do for second one. Now it will take more time. 0 1 2, here 1 2, here 1 2, here 1 2, it is 3. And 3 3 4, 3 3 4 4. It is removed. See, 0 1 2 1 2 1 2 2 3 3 3 4 3 3 4 and 4. So this is another example. Okay, so what we should do here, we are going to minimize this one. We apply some row and column operation. So what we will do first, so see, R3 tends to R3 minus 2 R2, and R4 tends to R4 minus 3 R2. Okay, so what we will get, 0 1 2 3 and 1 1 2 3, it is same. Now 2 minus 1, it is 2 minus 2 0, again 2 minus 2, it will be 0. 3 minus 4, it is coming 1, and 4 minus 6, it is minus 2. Now 3 minus 3 is 0, 3 minus 3 is 0, 4 minus 6 is minus 2, and 4 minus 12, it is minus 8. So you know that this is 0, this is 0, this is 0, only this part is left, so only we will consider this one. So we have to omit this one and omit this one. So you see 1 into, I am right, this should be written like this in matrix form. So 1 2 3, 0 minus 1 minus 2 and 0 minus 2 minus 8. Let me see if I have did any mistake. Yeah, 4 minus 9, it is not 8, it is minus 5. Sorry, please check it, student. It is minus 5. It is minus 5. Now you see these two elements are 0, so this, if you going this way, only this element will give you the answer. 1 into minus minus plus, and this minus minus plus minus 4. You will get total answer as 1. So you see, this is a 4 by 4 matrix, and its determinant also coming 1. Let's remove this one, and I am using this symbol. Okay, So this is the determinant. You have to first write down the matrix, right, like this. You have to write down the matrix, then you have to put a determinant symbol over there and apply row column operation. It will be very useful because if you go directly also you will get 1. I know that 11 students may know this one. If you go like directly, it is taking so much time. So to reduce the time, we have used this operation. If you go like this direction in column operation, only one element is non-zero, which is 1. All other elements are 0. So that's why it is useful for us to calculate the determinant. So likewise, if you see, let me clear it. This entire row, if you see, if you consider entire row also as 11 by 11 matrix, you will get 1 only. Just same way you have to apply row column operation, and under that you eliminate, you will get any one, you will reach any one consideration part where you have to solve it. Its determinant also, let us take it as a. So it's also determinant will definitely come 1. So 11 and 12 students, please try this one and let me know that you are getting the answers or not. Okay, so these are the options. So you see, whatever I have explained right now, that one also here written. This is the 3 by 3 matrix, you see, and its determinant is what? It is 1. We have solved here. Likewise, I have taken this 4 by 4 matrix also, and its also determinant is what? 1. Yeah, right now. Okay, let me tell you that why I have to take 3, not 2. Because if you see 0, 1, 1, 1, if you find out 0 minus 1 minus 1, so that's why we are not taking this one. So this is one kind of another drawback. Okay, but it is very small drawback, but actually the entire 11 by 11 matrix will give you one determinant, that is 1, and this is happened because of the property of this symmetry. This symmetry has given the symmetry has given one more idea, that its determinant coming is 1. You know that if you go like in general, you cannot solve this determinant of this 11 by 11 matrix, because mostly we always, so up to 5 by 5 matrix we are able to do. We can use row column operation and we can apply, but it is very big determinant 11 by 11 matrix. So we have only one option, that we will try some 3 experiments like this: 3 by 3 matrix, 4 by 4 matrix. You can also go for 5 by 5 matrix up to here. Up to here you can go and you can check whether it is coming 1 or not. Then definitely if you get 1, then it is clearly proved that this entire the determinant of this entire code table of 11 by 11 matrix is coming to be 1. Okay, so these are the some observations, and maybe some other observations we can get based on some experiment, some test. Okay, these are few observations we have collected from different experiment, different test. Now I have covered all the topics of I have covered all the topics related to Pythagoras code table. Now we are going to solve the problem. So now first question is the square root of root over 72 square plus 64 square. So generally you will do what? You will use the calculator and you will write on there 72 square plus 64 square and you will get, but not like that. Options are also given. Okay, so we have the technique that 72 square plus 64 square. So I have told you you have to check two things. First you check this is a two digit number. It is a two digit number and the difference between them is very close. You can see difference between them is very close. How much difference you have? 72 minus 64. Only 8 difference. Very small difference is there. So, but numbers are big. So for big numbers, we cannot predict which will be more, what we say, which is more profitable. So you have to do nothing. Just to see, you see two digit, two digit. So the resultant also having the decimal after two digit. So it is eliminated. Option C is eliminated. You can go like this because it is giving three digit is not possible unless some limitations may have, but it is not possible. So what we will go, we will check the table. Minute. Just students. Let's see the table. Here we can see you have to go the base at 7 and go to 6 as perpendicular. You will see according to the Pythagoras code table the answer is 9. Okay, so you can see that you getting what? 9. Okay, let me clear it. It is coming 9. So definitely some 9 will come and another one more digit to make it two digit, to that whatever the decimal places. So if you see that options, option B is visible to you, and now you can check the calculator. Okay, so here another question similar way. Square root of 81 square plus 24 square. So 81 square plus 24 square. Okay, so this is two digit, this is two digit, so obviously it will be a two digit number, then decimal will come. Okay, so if you see, yeah, just I have to make one thing that 7 and 6 you have to just check right now. The difference is 1 actually. I've mistakenly taken 72 and 64. That one not, you don't have to take. So if you see 8 minus 2 is 6, it is greater than 5. It is greater than 5. So 8 is more priority. So some definitely some 8 will come, and one more value will come digit then decimal. So if you check the options, C will be feasible to this option. Okay, so this is one, this is second option. This is second option, second question, third option. One more question like this, and here your options. So 49 square plus 46 square is giving you what? So it is two digit, so two digit, and then decimal will come. But what will be the first number will come? So 4 and 4. If you remember the Pythagoras code table, the answer will come 5. So some 5 will come and one more decimal. But you see, but you observe here that we have actually two options. Option A and option C are given. So if such case is coming, then only one option is left with you. You have to calculate. Under my observation saying that it has to be coming 53.21. No, but actually, because one limitation I want to share you that here, because of this 9, it is exceeding 5 and coming to 6. Answer coming is 67.2. Actually answer will come 67.2. So but here no option is given, so we have to go with option D. So you see, sometimes you may get you may struck in the options, so sometimes you have to very careful. You very much that you blindly believe that one option will come from option A and option C, but it is not coming, because after 4 if you take anyone from 1 to 6, like 41 or 42 or 43, anything you can take in both the values, you can have the limitations to the Pythagoras code table. But if you take like second digit like 7, 8, 9, like this, if you take, it is out of the limit. Okay, so let me clear it. Okay, so but these two options, previous two questions options are right, because the you see the two digit number, the ones plus digit number, all the numbers are between 1 to 6. Okay, so that's why we are having correct option. So this is the last question. So the square root of 18 square plus 73 square, 18 square plus 73 square. So two digit, definitely it will come two digit. You must remember the equivalent digit concept. Equivalent digit concept. So you see 1 and 7 are there, but as I have told you, here 8 is given, so 1 and 7 will give you some value of 8. So we can go with option C, and also we will check whether it is true or not. But actually it is not true. Sometimes this also may get some limitations. It is wrong. Right option is A. Okay. So option A is the answer. Now you some had advantages. So you can read it out. The codes can help in predict the square root of sum of squares of two big numbers of equivalent digits. This is the example. This is example. You please read it. Okay. If the difference between two numbers is very large, now I have explained, then the largest number with the equivalent digit will dominate the results. This is what means say if 8 minus 1 7, then you see 8 and 8. It is mostly dominating part. Okay. If the difference between two numbers is very small from 0 to 3, then the resultant of number of two numbers of equivalent digits will always be greater than that number. So it is the example. See here. See 21 and 18. So the number we are getting is greater than these two number. Okay. Similarly, in the first example, here it is 9, here it is 12, you are getting 15 because the difference between them is very small. Okay. In every point we are mentioning this equivalent digit. So you can see how much the equivalent digit is important for you. Okay. If the two numbers are of unequal digits, then the resultant of that will be of maximum digit of two numbers. So this is the first example. So equivalent digits, you see it is 4 digit, it is 5 digit, and resultant is also 5 digit. Maximum digit number is having more priority. Okay, see this one. So these are the advantages, but we have some disadvantages also. Just check it. Disadvantages: the second highest place value after the first highest place value contains numbers like 7, 8, 9, 10 in any of the two numbers, then a potential result will be exceed by one of the given Pythagoras codes. Just I have shown you one example. Sorry, that is the question I have shown you. If the two numbers are of unequal digits, then it may not follow the standard Pythagoras code table like this example. There may be other advantages or disadvantages of the code table found in further observations in the future. So we can have more advantages and disadvantages if we study more on this table. So I hope you all understand the concept. So till then, let me stop here. Thank you for learning.